inverse trig functions. So the inverse trig functions are when you are working backwards and you are trying to find what angle it came from. So it almost reminds me of Jeopardy. You know how when you watch Jeopardy, the show, they give the answers in the form of a question, like it's backwards? That's kind of what we're doing now. So far I've said, hey, what's the sine of pi over 6? And you've gone to pi over 6 and you've said 1/2. Now I'm going to say, if the sine is 1/2, where did it come from? So it's almost the opposite of what we've been doing. So you're going to tell me what angle. Now, do you notice, though, that if we play that game and I said, hey, what is the sine of 1/2? Do you see how there are two spots where that happens? Okay. So the reason we have these restrictions is because if we restrict it to these sections, we'll only have one answer. So when we look for inverse sine and inverse tangent, we can only look in this region. When we look for inverse cosine, we can only look in this region. The rest of it, bless you, I typically call them like no-fly zones. Like you can't go into them at all. So you can only be here and here. So for example, let's say your answer is here. Do you see how to get to 11 pi over 6? I'd have to go through the no-fly zone to get there. So we aren't going to use any of these as positives. When we come this way, they're going to have to be negatives. So this would be negative pi over 6 because that's the only way I can get to that spot without going through the no-fly zone. Does that make sense? Okay, so let's do some together. It'll make more sense when we do some examples and you kind of see what we're working with. Then I'm also going to show you how this gets applied to story problems because we tend to get a lot of story problems. Now, I know in life there are story problems that are tricky and there are story problems that are kind of like, oh, these make sense. These are the type that make sense. These are not the ones that you like sit at the dinner table and fight with your parents about, okay? We've all lived that. That's not this type of story problem, okay? Here we go. So take a look at the first one. So again, we are working backwards and we are asking the question, what angle did it come from? So we are looking for angles today. So that is the question you're going to keep asking yourself is what angle did it come from? And actually, I guess I didn't need you to get out your unit circle because this one's going to be better now that we have it highlighted. Okay, so go to, we're looking for what angle gave us root 2 over 2 for sine. So look at the yellow only. Where do you see root 2 over 2 for your sine value? Pi over 4. So this is again asking what angle. It was pi over 4. Pi over 4 has this as its sine value. So pi over 4 is your answer. So your answers are all going to be angle measures. And you know how your book's been giving you degrees? Again, that's something that typically doesn't happen. These are all going to be in radian measures. So when you're... What is the little... Oh, that means inverse. That's how we talk about inverses. So if you remember even back to... It's going to be on the exam review. I want to say it was like maybe chapter 6. Like anytime we refer to inverses, the notation is -1 for the exponent. Again, a note you might want to write yourself out here is radians, please. So don't give me degrees. I fully anticipate while I'm saying that your textbook is going to give me degrees because they seem to really love degrees. Okay. Cosine is up next. So cosine is the orange. So go to the orange. And we want an x value of 1/2. Where does that happen? What angle? Pi over 3. So we're going to write pi over 3. That's our answer. That's it. So these are like one step. They're kind of similar to the day we just worked with the unit circle where you're just using your unit circle to get to your answers. Next ones. Ooh, I didn't mention this yet. Do you see how this says tan to the -1 and this says arctan? Those are a tomato-tomato situation. They're both asking for the inverse tangent. I know it doesn't look like it, but they both are. And actually, before we do those, let me add an example 2.5. Let's do the sine of inverse sine, sorry, of negative root 2 over 2. So this is my example 2.5 before we go to 3. So find the inverse sine of negative root 2 over 2. 7 pi over 4. I agree that that's where we want to end. But remember, to get to 7 pi over 4, we'd have to go through the no-fly zone. How can we get to 7 pi over 4 without entering negative pi over 4? So remember, for tangent and sine, you're going to have to get to them from the negative direction, because otherwise you'd be going into the no-fly zone. So be careful with those. All right, the next one is a little tricky. So first of all, do you see that your tangent is positive? Okay, so look up here. Do you see how you're restricted to these two spots? If your tangent is positive, I can't live down here because, do you see how one's positive, one's negative? So if you do sine divided by cosine, these are all going to give me negative answers. So none of these are going to work. So the only spot my answers can be are up here. So let's start with that. So we can't have anything down here. We've eliminated this whole region because it would give me a negative tangent value. All right, so think about tangent. If you do sine over cosine, 0 over 1 is 0, so it can't be that spot. I'm just eliminating right now is what I'm doing. This one, look at this one. If I do sine over cosine, root 2 over 2 divided by root 2 over 2 is what? 1, so it can't be this one. This one's undefined. So do you see how there are two spots with potential? And I don't know which one it is, so I'm going to have to try it. So I'm going to do sine divided by cosine. So I don't know which one's correct. So the tangent ones kind of present a little bit of a problem. Instead of dividing, what's easier? Keep, change, flip. So keep, change, flip. My 2's cancel, and I get 1 over root 3. Can I leave my answer like that? We need to multiply top and bottom by root 3. So I get root 3 over the square root of 9. And what do we know the square root of 9 is? 3. Okay. So this is my tangent for this point. Does this tangent match this? No. But, ooh, did it help us with number 4? Okay. So my tangent is root 3 over 3. So where did we just figure out that happened? Pi over 6. So that's the answer here. So it didn't help us with the problem we were on, but it helped us with the next one. So, yay. Okay. The other spot that we have left that it could be is pi over 3. So let's try that one. And hopefully it works because it's our last hope. Sine divided by cosine. And again, do we really want to do that division? No, we're going to do our keep, our change, and our flip. The 2's cancel, and I get root 3. Did my tangent work out the way I had hoped? Yeah. So, where does that happen? It happens at pi over 3. So again, the tangent ones are going to be a little bit trickier than the others, because you're going to have to actually do the division. All right, the last two, we have to do 2 steps instead of 1. Remember, just like we always have, you start at the innermost set of parentheses. So when I get to number 5, this is going to be the first thing I do. I'm going to start in the parentheses. That is going to be my first step. So this is the first thing I deal with in the parentheses. So let's figure out what that is. So I'm going to rewrite my sign. And then in place of this mess, I'm going to put what it's equal to. So the cosine, the inverse cosine of root 2 over 2. So go back here. Cosine is which color? Orange. So we're restricted to this window in quadrant 1 and 2. Where is the cosine root 2 over 2? Pi over 4. So we're going to replace this with pi over 4 because those two things are equal, so we can sub it in. So this is pi over 4, so in place of this mass, I'm going to put in pi over 4. And now we want to find the sign at pi over 4. So our second step, so now we're on to step 2, so there are 2 parts to this one. So the second step is going to be for me to actually then take the sign of it and use the thing that was out front. What is the sign at pi over 4? Root 2 over 2. So you're going to find sometimes that you get the same answer as what was in parentheses. That's going to happen fairly frequently. So these are 2 steps. So when you get the parentheses like this, we have multiple steps. Sign is always y. All right, let's start at the innermost set of parentheses again. This is our first step. So again, this is my first step. Remember, arc sign is the same as the inverse sign, sign to the -1. Okay, so go to your picture. Remember, we're sign now, so we're in the yellow. Where is my sign -root 3 over 2? Negative pi over 3. So let's go there. So remember, negative pi over 3, we had to go this way because we couldn't travel through the no-fly zone. So at this point, is my y value -root 3 over 2? Yeah, so that is the correct spot. So I'm going to rewrite my tangent, but in place of all this, I'm going to write 5 pi over 3. Because I just calculated what that was. Okay, so what we just did was just the inside. So pretend nothing else is here for a minute.
Wait, so why can we write 5 pi over 3 now, though? If we can't.
Oh, no, it should be negative pi over 3. I'm sorry. That's my bad.
I was like, wait, what's switching?
Yes, it's the right spot, but we didn't get there the right way. Thank you. Negative pi over 3. Nothing changed. I'm so sorry. Was that your question too, Kendall? Okay, good. Now we fixed it. Okay, so go to that same spot, and it wants me to find the tangent now at that spot. How do I find the tangent? -root 3 over 2 divided by 1/2. Instead of doing that, though, what do we like to do instead? Keep change flip. So -root 3 over 2 times 2 over 1. What happens to my 2's? Oh, I lost my root 2. Disappeared. The winds from last night blew it away. Cancel out what?
The 2's.
The 2's. Agreed. By 2's. So I get just -root 3. And that would be my final answer there. Okay. So we're just kind of looking at the graph to help us get our answers. I didn't need the calculator. I didn't need anything else. We already talked about all this, so we are going to skip down to the 2 story problems because there are lots of story problems that we can come up with in this section. Are you ready? And notice what I wrote. You always have to add pictures. Okay? That's a firm rule for me. All right. So, we have Shrek, and he is climbing a 50-foot tall ladder. So, I'm going to make my ladder. We know ladders lean against stuff, right? Like, we're not going to have a ladder going straight up and down. That sounds dangerous. So, here's my ladder. It reaches 32 feet up a wall. So that means from here to here, this would be 32 feet. So we have a ladder, it's leaned against the wall, it went 32 feet up the wall. The ladder itself is 50 feet long. So 50 feet is this length right here. So the ladder itself is 50 feet. Do we agree the ground would be here? Because the ladder is not floating in midair, the ground should be under the ladder. Are you okay so far with what I put in? Okay. The wall should make a 90-degree angle with the ground, or do you really want to be in that building? Probably no. So 90-degree angle with the ground for the wall. The question is, what's this angle? What angle does the ladder make with the ground? So what's a good angle here? All right, so we're going to go back to our SOHCAHTOA for just a minute. If this is my theta, how does this side relate to it? Opposite. So I have opposite. If this is theta, although it doesn't really matter as much here, how does this side relate in the triangle? Hypotenuse. Okay, so I make a list of the things that I have. If I have O and H, which trig function would that have come from? Sine. Okay, so remember, we're thinking sine would equal opposite over hypotenuse. So I'm going to rewrite this. I'm going to write sine of theta equals, what's my opposite? Based on the picture, 32. What's my hypotenuse? 50. Okay. If we want to find the angle measure, do you know this fraction from the unit circle? Me either. So what you're going to do is on your calculator, whether you have scientific or graphing, actually first let's go to mode to make sure we're all in the same mode. If you have a graphing calculator, go to your mode, and we need to switch. These actually, when we do story problems, we typically do them in degrees. So switch for me, please, to degree mode. So story problems are degrees. The ones like we did on the front are going to be in radians. So hit mode, go to degree, hit enter so it's highlighted, and then hit second mode, and it'll quit you back to the home screen. Are we all here? And I think if you're on, we'll find out together, but I think if you're on a scientific, it'll automatically be in degrees. I don't know. Fingers crossed. We'll find out together. Okay. Think about when we're solving for a minute. If you had a square, you would square root to undo it, right? If you had multiplication, you would undo it with division. To undo a sign, because we're trying to figure out what angle it is. To undo a sign, we're going to do the inverse sign, like what we were just doing. So we are going to take the inverse sign of both sides. So on my calculator, do you see how above the word sign, there's sign to the -1? So hit second sign. Do you see how it pops up with that inverse? And then type in 32 divided by 50. How big of an angle did Shrek's ladder make with the ground? 39, so about 40 degrees. So approximately 39.8 degrees. And that's your answer. We're going to do another one. So if you're like, ooh, I kind of got maybe half of that, you got another shot. We're going to go through a different one. All right. The t-shirt cannon. Right? You've seen those before? The t-shirt cannon things that they shoot into the air. So here's the t-shirt cannon, and it is shooting a t-shirt into the air up into Spartan Stadium to the fans. Let's see. It went up 40 feet vertically. So vertically would be this side. So it went 40 feet up in the air. So that's the elevation piece of it. It went 35 feet horizontally. So where am I going to put the 35? Yeah, the bottom. So 35 is my horizontal component. Again, this is going to be my right angle. And it says, what's the angle of elevation? So the angle of elevation is, I have this t-shirt gun, but if I shoot it like straight into somebody's tummy, like that's not going to feel good, right? They'll probably be fine, but that's probably not the best, right? So I'm going to angle it up in the air. So the question is, how much did I angle it up? That's the angle of elevation. So we're looking for this angle. So let's think about what we have first, just like we did last time. How is 40 related to that theta? Opposite. How is 35 related? Adjacent. Okay, if we have O and A, what trig function am I? Tangent. So I'm going to need to set it up that the tangent of theta is equal to opposite over adjacent. So here we go. I don't know theta, that's what I'm looking for. I'm going to fill in for my opposite and my adjacent. What's the opposite? What's the adjacent? Okay. And then just like last time, how do you think I would undo a tangent? Inverse tangent undoes my tangent, and I have to do it to both sides. Again, just like any equation you would solve, you can't do something just to one side and not the other. That inverse tangent is going to make this cancel out, so I'm going to be left with just what my theta equals. So on my calculator, I'm going to hit second tangent, 40 divided by 35. So do we get 48.8? And notice I'm putting my little squiggly equal sign because it's not like dead on, but it's close. And put your little degree marker so we know what we're measuring in. How do we feel about those? Okay? So like I said, I know there are story problems out there in the world that are super tricky and frustrating and all of that. I don't think these fit into that category because I think it's kind of easy and intuitive to draw the picture and then set it up. So it'll be similar each time you do it, but it could be sine, cosine, or tangent. It's not going to be any of the other three, right? We know cosecant, we know secant, we know cotangent. It's none of those. You're always going to use sine, cosine, or tangent. And again, these problems, another note you might want to write is that we want to make sure we're in degree mode. So these are in degrees. The one on the front, we're in radians. Okay, so that was our last day of new notes. Woo! All right, so you